So this is a continuation of chapter 2 lecture. I have this very simple periodic table on here just to kind of point out a couple review things that you need to remember. So remember, the first column is called the alkali metals. Column next door is called the alkaline earth metals. Over here on the right, we have our noble gases. They used to be called inert because they used to think that they did not make anything or make any compounds. Halogens are the next door neighbor to the noble gases. And then the middle group here is called the transition metals. You will see on the bottom, they already labeled those two, the lanthanide and actinide series. Again, we don't deal too much with that. Do realize that these other columns here are a mixture of metals and metalloids and nonmetals, so they don't have naturally any name associated with it, but you do see it labeled as, say, the oxygen group or something like that. But again, there's not any real pattern to those. Remember that the first column is a +1, it becomes an ion. It's a +2 if it's an alkaline earth metal. Noble gases have no charge. Halogens are -1. Oxygen group is usually a -2. And then nitrogen is usually a -3. What I liked about this diagram is, again, the stair step that we have here divides what we call the metals and the non-metals from each other. So over here on the left are the metals. Over here on the right are the non-metals. And right along that staircase are called the metalloids. They have both properties of metals and non-metals. Okay. The only weird exception touching the staircase is, of course, aluminum and then palladium. I think that's palladium. Is that palladium? Palladium are considered metals, or they are considered metals. So again, anything along that staircase like silicon is considered a metalloid. But again, that's not going to be a huge focus for us. So then going back to what I gave you for review, we're going to talk about some of the ions that I had you kind of look at in your summer packet, so you may want to pull that out. Just some general things and some additional information about nomenclature for you guys that you need to be familiar with. You have nitrogen is going to be a -3 charge, as I showed you on the periodic table. Realize that I sometimes write the negative or the charge in front of the number. That's because when I went to college, back when dinosaurs were on the earth, that's how we used to do it. So if you see me do that occasionally, I apologize. It's just I sometimes just naturally go with what I learned. So you usually write the number and then the charge. So remember, anything off the periodic table that has a charge, if it is a negative, is going to end in IDE. So N3 minus is nitride, oxygen is oxide, and usually oxygen is a -2. But we have a couple different varieties of oxygen that you may have not known about. O2, so when you have like hydrogen peroxide, it actually, the O2 itself has a -2 charge overall. So it's called a peroxide. So that's something new. And then this one is one of my favorites. O2 minus is what we call a superoxide. And how you know what the charge happens to be is by what it's attached to. So if I have sodium, and we know sodium is in the first column, it's the alkali metal, it's attached to O2, has no charge, so it must be sodium superoxide, So again, those are going to be two additional ones that you kind of need to be aware of. Hydrogen has, of course, a +1 charge. It's in the first column, even though it's not an alkali metal. But you could also have something called a metal hydride. So hydrogen could have a -1 charge if a metal is attached to hydrogen. Hydrogen's listed second. So in this example, this is potassium hydride, so KH. Potassium is always a +1. So if you have a hydrogen attached, hydrogen is listed second, usually it's listed first, then you know you probably have a hydride. Transition metals, again, that middle group that I pointed out on the periodic table, and you will see a bunch of them on the chart that I gave you. They have different charges. Do note that for their naming system, all I want you to do is what we call the systematic name, or the Roman numeral naming system. You don't need to know the classical name. If you want to use it when I'm asking you to name things, you can. But it's not required for this course, and it's not on the AP test. So you just need to know whatever the charge happens to be. If it's Roman numeral, that's going to be the charge of that ion. And that is only for transition metals, of course. So on the bottom here, I have ionic compounds compared to molecular compounds. What's the difference between the two? So ionic compounds have charges, okay, while molecular compounds have no charges, okay? And if you remember, make an ionic compound, I have to get those charges equal to 0. Ionic compounds are a combination of metal and non-metal. So something from the left-hand side of the periodic table versus something from the right. Molecular compounds are only non-metals. So you could tell by what is attached usually. So our metals are going to be the cation, and our non-metals are going to be the anion. So you always list the positive and the negative. Ionic compounds, there is a transfer of electrons before that compound is made. Remember, anions are going to end in IDE. That's how we name the system. Unfortunately, for molecular compounds, it's the same way. Now, molecular compounds, you are sharing electrons, but they do end in IDE as well, unfortunately. It'd be nice if they had a different system. Now realize if they don't end in IDE, that's generally because they are what we call a polyatomic ion. So this was the list that I gave you in your summer packet, okay? So these are what we call polyatomic ion. So polyatomic ion, you just have to be aware of their naming system. You're just going to memorize some of those names. I'll give you some hints here. Example I like to always show you is this one. Fe3PO42, okay? So you should recognize this as a polyatomic ion because you have more than 2 elements attached together. And you got a 3 down here and a 2. Well, iron can be either a +2 or a +3, okay? So iron can be a +2 or a +3. So which one is it? Well, you have to know what PO4 is. So PO4, when you look on your list here, PO4 is phosphate, okay, and it has a -3 charge. So if that has a -3 charge and there's 2 of them, in order for this to get to 0, iron must be the +2 variety. Now, there's sometimes a phenomenon where that bottom subscript agrees with the opposite's charge, okay? So we're going to call this iron 2 because it is the +2 variety. It has nothing to do with the fact that you have 3 irons there. And then you call it phosphate. Okay, you just call the polyatomic ion what it is. The good news is you just call it what it is. The bad news is you have to memorize it. Okay. Now, molecular compounds, we don't deal with these too often, but we do occasionally run into them. They're going to use a prefix system because they don't have charges to dwell upon. So we're going to use prefixes like mono, di, tri, tetra, so on and so forth to say how many of each one of the elements do we have. So you know one or 2 examples, CO2 versus CO. CO2 is called carbon dioxide, okay, and CO is called carbon monoxide. Okay, now realize with carbon monoxide, you kind of drop the extra O there with the mono and the oxide. That's just kind of a schematic kind of thing. But do realize that with both of these, I have 1 carbon for each one of these, but I don't put mono in front, okay? Mono is never part of the naming system if the first element is only 1. So just keep in mind carbon dioxide versus carbon monoxide, and hopefully that will help you to remember. Now, do be aware that there are some polyatomic ions that interfere or kind of mess you up a little bit with the molecular compounds. So if it has no charge up here, okay, if you see no charge, it's a molecular compound. If you see a charge, then it's a polyatomic ion, and you have to remember what it is. So NO2 is going to be nitrogen, again, not mono, nitrogen dioxide. Okay, well, NO2 minus, looking it up on your table, okay, NO2 minus is nitrite. Okay, nitrite. So again, that's a pretty easy mistake to make, so keep that in mind. So you're going to have to know ionic versus molecular and the difference between the two.